Or now I'm recording. The numbers are pretty big, right? So we're just going to use Desmos for this. And okay. So I'll just type those equations in. Don't have to solve them for y. 26x plus 42y equals 9434. And 49x plus 41y equals 10,721. Okay, and so I don't see it on the graph, which means I need to probably zoom out a whole bunch. Right, so if I zoom out, eventually I can see that intersection. Okay, now one thing you can do on these too, because a lot of this, when you're doing a test like this where you're using technology to answer questions, which is why we have technology in math, to help us get the answers to these questions. There's some things you can do on the graph too that I'll just show you really quick. I mean, this is, if you want to make the graph look better, sometimes the lines are really close together and it's hard to tell where the point of intersection is. You can do things like if I click on the wrench, I can choose for the x-axis, I can choose what I want the left edge of the window to be and the right edge of the window to be. So if I want to, like, I could like zoom out horizontally and pull those lines so you can see the spacing between them better if I use a smaller interval surrounding that solution. So instead of going from like negative 100 to positive 100, if I went from negative, well, if I just surrounded that point right there, so if I went like from 60 to 70, then it would stretch that thing out horizontally and the lines would, you could see the angle between them better. You can do some little tricks like that, right? You can sort of control exactly where you want that window to be. Most of the time you don't have to, but sometimes you do. Okay, so then in this case, what's our solution? 64 and 185, that's it, right? So I'll take a picture. Okay, so this is telling us then that what's it telling us here? It's telling us that the x-coordinate, so that's x, right? That was the number of, we defined that as the number of graphing calculators. So x is 64 and y is 185. So we just answered our question. Okay? All right, so next part, graphing linear inequalities. This is the second part. This is, if you can graph a line, you can graph a linear inequality. It's not much harder at all. So if you think about the steps that go with graphing a linear inequality, most of it's the same as graphing a line. First thing is we're going to put it into slope-intercept form, just like we would if we were graphing a line. We're going to graph the boundary line, right, just like we normally would. The only thing we have to keep in mind here is that if the inequality includes an equal sign, then the line is part of the solution, and so we're going to graph it as a solid line. If the inequality doesn't include an equal sign, then we don't include the boundary line, so it's just dashed. Then the only really extra piece to this is just which part are we going to shape, and we determine that based on the inequality sign. Okay, so let me get some help here. So let's do this one. So Hunter, we got to put these into slope-intercept form. So we got to get the y by itself. All right, that's the first step, right? Get the y by itself. So what are the steps? What do I need to do to get that y by itself? Subtract 4x. Good. If I subtract 4x, what am I going to get on the left side? 4y. What am I going to get on the right side of the inequality? Plus 16. Okay, what's next? Divide by 4. All right, so if I divide by 4, the 4's are going to cancel, right? So I'm going to get So I'm going to get y is greater than, what am I going to get here? Negative 1, so I just write that as a negative x, right? And then 16 over 4 is, okay, so then if I wanted to graph this, this would be easy to do, right? This is going to, the boundary line is going to be dashed or solid.
Dashed.
It's going to be dashed because I'm not including an equal sign. If I wanted to graph the line, where would I start?
You start
On the y-axis. The y-intercept is 4, so I go up the y-axis to 4, and what would my slope triangle tell me to do?
rise 1, but down.
Okay, so I go down 1 and over 1. I create my boundary line, and then here's the only part we got to really focus on. Am I going to shade above or below the boundary line based on that? Above, right? I want y values that are greater than the boundary line. So I'm not even going to, I'm going to skip this example so I can be a little faster. Let's just jump right into systems, okay? So systems of linear inequalities, remember what we said about that. A system just means more than one. So we're just going to graph and shade each inequality, and where they overlap, that's going to be the solution of the system. Okay, so let's just do this one, and if we can do this one, we're good, right? Then you can, if you can graph this, you have to graph inequalities to graph the system, and so, we won't even do them separately. Just graph the system. So let's make this one blue. How about? And let's go through the steps to isolate the y. So just think what those are really quick in your head. What are those going to be? I need to grab something quick here. Whoops, that's not what I want. I gotta grab like.
Yeah.
Where'd they go? There they are. Okay, so if we're gonna solve this one for y, what are the steps we're gonna do to get the y by itself? Subtract x. Okay, good. So if I subtract x, what am I gonna get? Oh, I'm gonna get a negative 3y on the left. What do I get on the right?
Negative x minus 15.
Okay.
Divide it all by negative 3.
Divide by negative 3. So if I divide everything through by negative 3.
You gotta flip that sign on.
Okay, I got to flip the sign. Good. So if I'm dividing by negative 3, I'm going to get a y on the left. Because I'm dividing by a negative, I've got to flip the inequality, right? And now here's the other thing I want you to sort of focus on. So what am I going to get? I know that on the other side I'm going to get mx plus b, right? So we want to know what m is. Well, m is what's multiplied by x. So it's going to be a fraction this time, isn't it? What's in the top of the fraction?
1.
Well, okay, but it starts off being negative 1. So I got a negative 1 on top, and I've got a negative 3 on the bottom. Negative 1 divided by negative 3 is 1 over 3. I can't reduce the fraction. Negative over negative is positive. So I'm going to get a 1/3 x. And then negative 15 divided by negative 3 is plus 5. So let's graph this then. Where do I start? Where am I going to start with this one? Up 5. Okay, let's see. Rise 1, run 3. My boundary line is going to be dashed or solid. It's going to be solid. I'm including the equal sign.
And it's above.
And it's going to be above. Because look, we want the values of y that are above the boundary line, above mx plus b, right? So
I think in purple. No.
you're right. Okay.
Next one's gonna be red, and together they're gonna be purple.
There you go. I need to change it up a little bit, don't I? Okay, so now what am I going to do here to get the y by itself? Add 5x, good. So I get negative 3y is greater than positive 5x plus 3, right? Divide by negative 3, good. So we get y is greater than, oh, I gotta flip the sign. You're right.
You silly mongoose.
Okay, so we gotta flip that around. I get a positive 5 divided by a negative 3.
Negative 5/3.
Positive 3 divided by negative 3. Okay? So then when I graph this thing, I'm gonna start at negative 1. I'm going to rise by how much?
Negative
Negative
5.
5.
So I'm going down.
Negative 5.
I'm gonna run by
3. This.
dashed or solid.
Dash.
Okay. Okay.
And below.
And I'm shading below. All right. So if I'm shading below,
Why do you gotta do that? Come this or this.
so then the double shaded region, the overlapping region is just up there, isn't it?
Yeah.
Right. And I've got a solid boundary and a dashed boundary. Okay? So that's it. No big deal. Okay?
Now we're done?
Almost.
Oh, my.
Okay, this one we can do in about 10 seconds. If this one's easier, but it's unusual. So it's sometimes people. What's my bound? Now, hey, don't shout it out loud. I want hands this time. What's the boundary line going to be? It's going to be dashed, but what's it going to look like? It's going to be, yeah, it is. It's going to be y equals 4, right? I mean, the boundary line is y equals 4, which is going to be a horizontal line that cuts through the y-axis at 4. I'm shading above or below? Above, okay.
That's like the third time you've done that.
Okay, this one, where's the boundary line? Okay, and it's dashed or solid? And I'm shading above. So where's the overlapping region? Okay, so it's everything just above the top boundary line, right? Okay, you get the idea? Okay, we're almost done. The last one. Sorry, last one. I know this took a little longer than I thought it was, but this will be quick.
Last one, like, problems ago.
Oh, I guess I lost track.
Oh, I guess.
So we can do this quick. Now, you don't have to graph anything on this. All I want you to do is to be able to set up the system of linear inequalities, right? So we can be very quick with this. It gives you the variables. It tells you if B represents the number of hours this guy babysits and Y represents the number of hours he spends doing yard work. And here's the situation. He's babysitting, he's trying to save money for some video games. Jack babysits for a rate of $6.30 per hour and does yard work for $9 per hour. His parents said he can work no more than 32 hours to ensure that his Algebra 2 grades don't suffer. And he needs at least $242 to buy the video games. Okay? So can we come up with some mathematical expressions that replace the words here? So how about this one? What if we want to say we know he's babysitting for $6.30 per hour and doing yard work for $9 per hour, and he needs at least $242. We need some expression here that's going to tell us how much money he's making, right? Okay? So if B is the number of hours he babysits, and he's making $6.30 per hour babysitting, how much money is he going to make babysitting? Well, that's what B stands for, is the number of hours.
630B.
Ah, okay, so we're getting 6.3B, right? That's going to be how much money he's making from babysitting total. How much money is he making from yard work total?
9.
Okay, but what about this? he needs at least $242. So would 240 be enough? No.
No, it won't.
242 would be fine. Would 245 be fine?
Yeah.
Yeah. So what am I going to say then?
Greater than equal.
Greater than or equal to 242. Okay, what about this one then? What if it says his parents say he can work no more than 32 hours? We can't go over 32.
Y. B plus Y.
Ah, okay, B plus Y, so number of hours babysitting
Equal
plus
to
number of hours yard work has to be,
less than or equal to.
ah, there's the question. So do we put in equals? Would 32 be fine? Yeah, his parents would allow 32, right? But they just wouldn't allow anything more than that, so we'd have to have a less than or equal to, right? So that's our answer. So this is the answer. That's our system of linear inequalities. We're done. Okay, work.